So today we're going to take a look at section 9.2, just part 1. It's on polar coordinates. All right, so yesterday we looked at parametric equations. Okay, parametric equations, it's a different way of writing the equations you're used to writing, but it still is done on an xy axis. Okay. Polar is a little different. Okay, polar is done on a circular grid. Okay, we're not going to use a rectangular grid for this. Up until now, rectangular coordinate system, that's probably what you've used quite a bit, and that's what you're familiar with. Unless you've done some like 3D animation. Someone said they use the polar and drafting. Was it drafting?
Yeah.
Do you do a little bit with polar?
Mm-hmm.
And kind of ultimately our goal here is we're going to learn the connection between parametric and polar tomorrow and how to convert one from the other. All right, so you guys already know how to take something that's parametric, and if you can, eliminate the parameter, turn it into like function notation. We've learned how to take anything that's in function notation and change it to parametric, just using those two simple equations, x equals t and y equals the original formula, change all your x's to t's. So you can change between parametric and function both ways. But eventually we'll learn how to change polar as well. Okay, so that's what a polar grid looks like. The center here, you can call it the origin, but it's generally called the pole. Okay, and this horizontal line, that's the x-axis. I don't think they mention it in our book, but that's called the polar axis. And on this particular type of graph, each of the lines going up are 15 degrees. Just the way they're spaced, every 15. Right, so when we graph something in polar, it's a little different than xy. We're not going to be moving left and right and up and down. Okay, that's more rectangular. We're going to have a distance, okay, which is going to be a radius. And the distance is going to be measured from the pole. How far out do we go from the pole? And then we're going to have an angle. Well, there's two directions you can go in for each one of those numbers. If r is positive or negative, it changes which way we go. And if the angle is positive or negative, that changes which way to go. All right, so how do we graph the point? Well, if r is positive, you're going to start at the origin, you're going to go to the right. How many units? Well, whatever r is. So if r is 4, you'd start at the origin, and you'd count out 4 rings. If r was 2, start at the origin, go to the right, 2 rings. And you can go in between rings as well. If it was 2.5, go in between the second and third ring. If r is negative, you're going to go to the left. Right? So if r was -5, you'd count left 5 units and start 5 units left. So any question which way you move for r, left or right? All right. Once you move left or right, from that point is where we're now going to move the amount theta says to move. Right? Well, when we move on an angle, okay, that's movement on a circle. We don't describe movement on a circle as left and right or up and down. What are the two directions you can go on a circle? Yep.
Clockwise, counterclockwise.
You either go clockwise or counterclockwise. Well, it's the same way we've been measuring angles all year. If you have a positive angle, that's counterclockwise. If you have a negative angle, that's clockwise. The important thing is that you do your movement of theta from where you ended up in step 1. Right? Just like if you were graphing on xy. And I said to graph the point 2, 3. Well, you go right 2, and then you go up 3, starting from here. You wouldn't go up 3 back starting from the origin, because it already said go 2 to the right. and then from there, go 3 up. Right? So same idea. Take care of r by moving left and right, and then wherever you end up in step 1, then move the number of degrees indicated by theta. Okay. Positive counterclockwise, negative is clockwise. Okay, so what we'll do, we'll just practice changing, graphing points. Sometimes you might have to change degrees to radians, or radians to degrees, depending on which one you're comfortable with. I think generally most people prefer the degrees. So if you get something in radians and you don't like it, we'll convert it. All right, so let's graph that point. All right, so first thing you want to look at is the 3. All right, so Julia, from the origin, I'm going to move 3 units which way?
To the right.
Yep, 3 units to the right. All right, so I'm going to start 1, 2, 3. So I'm starting from right there. Now I have to move 45 degrees. Justin, in this case, I'm going to go 45 degrees which way? Counterclockwise. Right, so that's going to be like that. And that's it. That's your answer. And as far as graphing, that's all we're going to graph today. Points. We can graph pictures like we did parametrically. Polar is really, really good for graphing circles. It's very, very simple. But we'll look at that tomorrow. Okay. Any question on graphing that point? Let's try another one. Okay. Negative 275 degrees. All right, so Carly, which way am I going to move this time?
To the left.
We're going to go to the left. How many rings from the origin?
2.
Yeah, I'm going to go left 2. So we're going to start from right here. And now from that point, I want you to move 75 degrees. We just have to figure out our direction. Okay, Brian, what's our direction this time? 75 degrees.
Clockwise. Or counterclockwise.
All right, what kind of angle is that?
Acute.
Positive or negative?
Oh, negative. Are we talking like below the axis or above?
So this is positive 75 degrees. Positive angle. So which way is it for positive 75? Counterclockwise or clockwise?
Clockwise.
Counterclockwise. Okay, positive angles. If theta is greater than 0, which in this case it is, it's 75, move counterclockwise. Okay, any questions on that? All right. So we've gone left 2. Now go 75 degrees counterclockwise. Okay, so the opposite way a clock goes. Okay, that would be about right there. Okay, if I went all the way down to the negative part of this axis, it would be 90. So just go a little bit before it. Okay, any question on that? Okay. All right, so let's try this one. This time it's a positive radius, negative angle. Okay, Tahina, which way would I go this time?
To the right.
Yep, to the right, how many?
3.
3. So we can go right 3. And then from there, Michael, I'm going to go 60 degrees which way?
Clockwise.
Clockwise, good. So if I went right there, it would be 45, a little bit more, 60. So it's about 2/3 of the way towards the negative part of the y-axis. Any question on that one? Great. Let's try. I've got a whole bunch to try. We don't have to do them all. Okay, let's try one with radians. Okay, first thing we might want to do is, if you're not familiar with the radians enough to visualize it, let's change it to degrees and see where we end up. What's negative 3 pi over 2 in degrees? Yep.
Negative 270.
Good, negative 270. Right, so Nick, what would be my first step here to graph the radius? I'll graph where we're going to start from that.
Go 4 rings to the left.
Yep, 4 to the left, and then from there, 270 degrees which way?
Clockwise.
Clockwise. Okay, so that's going to end me up right there. Okay, any question on that? Okay, so this time we went 4 to the left, and then we went 270 degrees clockwise. What's a different way to get to that point besides negative 4 and negative 270? Yep.
4, negative 90.
4, negative 90. Yes. So if you did it that way, you'd be going 4 to the right, and then negative 90. Okay, so that's a second way. How about a third way? Yep.
Negative 490.
Let's see, negative 490. Yes. Okay, that one would be going like this. Negative 490. And there's one more way. If you look at the pattern, you have a negative, negative, positive, negative, negative, positive. So we're looking for a positive, positive. That's the last one. Yeah, Brian?
4270.
4,270. I think the last way is generally the easiest. Just keep both numbers positive. It's not the shortest way, but 4,270. Okay, so what I'm trying to show you with this one is, in general, there's 4 ways to get to any point in polar. You can go left and right from the origin, and then from there you can go clockwise or counterclockwise. Now, if you did something like this, say you went left, and you made an extra revolution before stopping, that's not a different way. That's a repeat of go to the left and go clockwise. Okay? If you go around 6 or 7 extra times, that's not any different. Okay, so any question on that? Now in rectangular, does something like that happen? Like if I want you to get to the point 2, 3, and I told you that was the point. How many other ways can you write this coordinate and still get to the same spot? None. Yeah, you can't. All right, if you want to get to the point 2, 3, you have to write a 2, you have to write a 3. They both have to be positive. You don't have these different ways to do it. Okay, if you include writing all these in radians, then I guess that would be 8. But degrees are radians, just a different unit of measurement. Right, how about this one? 0 pi. How would you graph that? Yep.
Wouldn't it stay at the origin?
All right, so our radius is 0, so we stay at the origin. But how about the pi? What's that going to do?
180.
Yeah, 180 degrees.
So it would stay on the same axis. And then it would just stay in there.
Yeah, it's not going to move.
Okay, yeah,
Alright.
that's what I was trying to say.
So basically what that 180, or what the pi is doing, is it's going to spin in place. All right, so when you graph this one, just make sure when you put your pencil down, just rotate your pencil halfway. Just like that. Because it's a 180, it's halfway. All right, anytime you have 0, comma, any angle, it's always at the origin. How about if we switch it? Is this going to be at the origin? No. Where's this one going to be? Orlando?
2.5 to the right.
Right.
Origin.
So you go 2.5 units to the right, and we don't move at all for the angle. So stay right on the positive x-axis. Okay, any other questions on graphing? We've looked at every case. Positives, negatives, and then zeros. All right. So we've already pointed out what I'm explaining right here. There's more than one way to graph a point in polar. It's four basic ways. And now we're going to look at how we can change a polar point to rectangular. Okay, and by the way, my reason in showing you the 4 different ways to graph a point is if you get a multiple choice question and your answer doesn't match what's listed, maybe they picked one of the other 4 ways to write the answer. Right, so you should be able to take any answer you get and change it to any of the 4. The easiest way to do that is on paper. Draw your point and then trace it out on paper the direction you'd have to go. To do it in your head, it's kind of hard. You could come up with a set of rules for probably doing that. Like, is it, if you have the positive, negative, basically you just make the other one negative, make the other one positive, and that seemed to work in this case. Or do you add 180? But honestly, I just draw it and sketch it. So I don't have to think about fancy formulas to do it.
There always will be 4.
Unless it's at the origin, then that's kind of a special case. Yep. But other than that, as long as you're not at the origin, there's always 4 ways to get to a point. Now, if you were, let's say you had a point like that. Well, one way you could do it is just to go to the right and go 0 degrees. You don't have to move at all. Or you could go to the left, go halfway around that way, left, halfway around that way. So there's 3. But because it's right on the axis, I'm not sure you're going to get a 4th way. Unless you count going to the right and then making a full revolution as one, and going to the right and a full revolution the other way. But they probably wouldn't do that. They're usually going to represent the angle between 0 and 360. So why would you go to the right and then make an extra revolution when you don't need to? Yep. So next thing we're going to do is look at how we change polar to rectangular. Okay, let's say we have this point. If it's in polar, what are the 2 things I know about this point? Yeah?
You know the distance from the center and the angle.
Okay. I know the distance from the center, which is, what do we call that?
The radius.
The radius. And the angle we usually use which letter?
Theta.
Theta. Good. And theta is the angle between the radius and the positive x-axis. I drew it in quadrant 1 because it's going to make the shape I'm about to make easier for you to see. Okay, I'm going to add in a vertical segment here to make a triangle. Okay, specifically a right triangle. Okay, so all about that. And now my goal, instead of writing this in polar, I want to know what's my horizontal distance, okay, how far to the right, and then I want to know how far up. If I can figure out the length of that line in red, or segment in red, segment in green, then I'll have an xy coordinate. Okay, first we got to give names to those 2 segments. Well, since that segment in red is along the x-axis, call it x. Okay, the green segment runs vertical. Let's call it y. How could I get a formula for x and y? And somehow I'm going to be using r and theta. Yeah?
Just take the trig identities and the Pythagorean theorem and somehow work them around to get an equation.
All right, well, we could use the Pythagorean theorem if we knew 2 out of 3 of the sides. But in this case, you only know r. You only know 1 out of 3. So we're missing the x and we're missing the y. But we know this angle.
Yeah, so you know all the angles not by default.
Yep, we could figure out all the angles if we wanted to. It turns out you're only going to need this one. But you're absolutely right. You could subtract theta from 90 and get the other one if you wanted it. But let's just use the one that's given. Yeah?
Could you use the inverse sine and cosine to find the other two sides?
You can use inverse sine to find a side. Now, when we use inverse trig,
I mean, just sine and
just, yeah, exactly. Just sine and cosine. Good. If you were using inverse sine and cosine, that would be like to solve for an angle.
Yeah.
But yeah, we'll just use sine and cosine. Right? So if you write down cosine of theta, that's adjacent over hypotenuse. If you multiply each side by r, you get a formula for x. X equals r cosine theta. Okay, so if you have a point in polar, and you know its radius, and you know the angle, and you want to find the x value of that coordinate, take the cosine of the angle, multiply by r. Okay, what do you think the formula for y is going to be? R sine theta. So again, if you're given a radius and an angle, take the sine of your angle, multiply by r. That'll give you the y value of your coordinate. And together, put those both between a set of parentheses, put a comma between x and y. You got a coordinate in rectangular now. Okay. So we're not really learning any new trig here. We're just going back to right triangle trig, and we're going to use that a lot this week. Okay, any question on those two formulas? All right, so let's try this one. All right, convert 2 negative 200 to rectangular. If we get any decimals, we'll round 2 decimal places. Go to 2 decimal places. Okay, don't have to give me the final answer yet. I just want to know, what is my formula to find x? It's what times the trig function of what? Yeah?
R times the cosine of theta,
R cosine and what's theta?
negative 200.
Negative 200. Okay, so we'll do that one out. And my formula for y? About Shannon. What would that be?
2 sine negative 200.
Good. 2 sine negative 200. Okay, type those in. Make sure you're in degrees, not radians. And see what you get. Since 200 is not a multiple of 30, it's not a multiple of 45, we're not going to get nice answers here. Some angles that have multiples of 30 or 45, you will get a nice answer. Not this time. Okay, so we get negative 1.88 for x. And let's see, for y. .68. Okay, so now just write your final answer. X, comma, y. Okay, any question on that? What I'm going to do is, I'm going to graph the original point they gave me. And then I'm going to, on a polar grid. And then I'm going to take a rectangular grid and I'm going to drop it right on top of the polar one. And if we did everything right, the point should automatically be right at that spot. All right, so do I have a polar? Yeah, I've got a polar grid. Let me graph 2, negative 200. In fact, I think I already have it. So go 2 to the right. Okay, halfway around would be negative 180. And each one of these lines is 15. So if I go up to the next line, that's negative 195. And I got to go just a little past it. Okay, so that's pretty close. 2, negative 200. Any question on how I graph that? All right, so now let's take a XY axis, put it right on top of that, see if it lands right where it should. Okay, I have to use the XY axis that has the same scale as that. So I think it's this one. Okay, so let's check. So negative 1.88, just a little bit before 2, and then up 0.68, that's up a little bit more than half. So it looks pretty good. So that's exactly where the point should have ended up. Okay, any question on that? So if you do this on any kind of computer software, you can check your answer. If you could just change the background behind your point, that basically changes it from polar to rectangular. That's all I did. Okay. The graphing calculator, I don't think you can do anything quite like what I did there. All right, this one. I would expect to get at least a nice answer for one of my coordinates, or one of my x or y values. Because 5 pi over 6 is a nice angle. It's 150. Okay, it's a multiple of 30. I wouldn't even bother changing it to degrees, though. Just change your calculator to radians. And let the calculator figure it out. Okay, so x is 3 cosine 5 pi over 6. And y is 3 sine 5 pi over 6. Right, so we get 3 cosine 5 pi over 6. Okay, not a nice answer for that one. Negative 2.60. For the next one, we will get a nice answer. 3 sine 5 pi over 6. 1.5. Or as nice as you're going to get. Okay, last step, just make sure you write it as a coordinate. So negative 2.60, 1.5. Okay, questions on changing a polar coordinate to a rectangular coordinate? Okay, if you understand how to change a single point, that's the first step in being able to change an entire equation in polar to a whole new equation in rectangular. Okay, but we're just starting out with one point at a time. All right, so what else do you think we're going to eventually learn how to do? If we can convert from polar to rectangular, what can we probably also do?
Convert rectangular to polar?
Yeah, we can change rectangular into polar. Right? And that's the next thing. And I think this will be the last thing for today. Okay, so just like I did before, I set up a diagram, put a point on the circle. In fact, you know what? I can set it up so you can watch me do it. So draw your XY axis. Okay, let's put a circle on there. Put a point anywhere you want, but put it in quadrant 1. And it's rectangular. So in rectangular, we're going to know the x value and we're going to know the y value. So we know how far over to the right, and we know how far up. If we're going to change it into polar, what are the two things I need to find? Not the x and the y, I need
The radius and theta.
Yep, I need the radius, which is r, and I need theta, which is right there. That's x, that's y. The diagram looks very similar to the the last one we did. The only difference is the pieces of information you know. Now we know two sides in that triangle. Okay, so how could we find r or theta? We need to find both, and they're separate in how you do them. Nick?
You can use the Pythagorean theorem to find the radius.
Yeah, you can use the Pythagorean theorem to find the radius. Okay, and on the next page I have all these formulas and steps written out. I'm just kind of showing you where the formulas are going to come from. So x squared plus y squared equals r squared. There's your Pythagorean theorem, and that'll give you the radius. Just plug in x and y. What about theta? Somebody said something earlier that I think we are going to use, because we have to solve for an angle now.
The inverse sine and cosine.
Sine and cosine both have hypotenuse in them. I like the inverse, because you're going to solve for an angle,
Oh,
but let's try to avoid using r, because we don't know it.
inverse tangent.
We're going to use inverse tangent. Yep. So if you write down the tangent of theta, okay, tangent of theta would be y over x. Well, to get tangent by itself, take the inverse tangent of each side. So theta is the inverse tangent of y over x. Just solving for that angle in the right triangle. Now, this formula will work fine under certain conditions. Does anybody remember when you plug inverse tangent into the calculator, you hit enter, you always get an answer that's between two angles. Negative this angle and positive this angle. Anybody remember what those two angles were? It's also the same when you do inverse sine, except inverse sine, you can include the endpoints. Inverse tangent, you can't. If you go right to the endpoint, you have an undefined value. Remember that? Think about the graph of tangent. Where do you have vertical asymptotes? Or think about the graph of inverse tangent. Where do you have horizontal asymptotes? Think about it either way. Nick?
90 and negative 90.
Very good. Negative 90 and 90. So anytime you do inverse tangent, you hit enter. Okay, the values you're going to get are going to be between negative 90 and 90. You're never going to get an answer that's outside of those two numbers. Where does that mean all my answers are going to be in this grid? Which quadrants? If they're between negative 90 and 90.
1 and 4.
They're always going to be in 1 and 4. There's negative 90 to 90. What if we have a point in quadrant 2? That formula wouldn't work. Right? So we have to make a small adjustment to it to basically get the other half of this circle. Okay? And if you can think about what you could add to get numbers on the other half, that's basically how we do it. Okay? So I'll show you how that works. Right? So when you're converting, first thing you want to do is graph your point. The main reason you want to graph your point is to determine theta. Okay, when you're determining theta, the formula you use depends on the quadrant you're in. For quadrants 1 and 4, you can use the formula we just figured out. Inverse tangent y over x, it'll work perfect. But if you're trying to get an answer in quadrants 2 or 3, how would you know your answer is in quadrant 2 or 3? Well, in step 1, you're going to graph the point they want you to convert. Once you graph it, you'll know your quadrant. And just as a reminder, in case we forgot the quadrants, if you're in quadrants 2 or 3, basically the same formula, except you have to add pi on the front, or 180 if you're in degrees. What that does is it basically shifts the answers 180 degrees over. So instead of being on the right half of that, quadrants 1 and 4, Now we're on the left half, quadrants 2 and 3. So now we have a formula if the angle is in quadrants 1, 2, 3, or 4. But that still doesn't cover everything that could happen. Where else could my angle be? Besides quadrants 1, 2, 3, or 4? Yeah?
On the vertical axis.
Okay, it could be on the y-axis, which is especially a problem to use this formula. Where else could it be? Yeah?
The x-axis?
The x-axis. Anybody tell me why the y-axis would be a big problem? You had a point right there, and you tried to use either one of these formulas to solve for the angle. What would happen?
The denominator would be 0.
Yeah, the denominator would end up being 0, exactly. So if x is 0 and you try to divide by it, you're going to get an error. Okay? So if you're on an axis, don't try to use these formulas. Bad things are going to happen. You just have to know if you're on an axis. It's either 0, 90, 180, or 270. Those are your 4 choices. How do you know which one's which? You just have to memorize. Right is 0, up is 90, left is 180, down is 270. And this covers all the cases you could have for finding your angle. In a quadrant, on an axis. Okay, last thing is to determine r. Some people like to do this right away. You could. If you want to find that first, that's fine. Just the Pythagorean theorem. And this formula is the same no matter what quadrant you're in. Okay, anybody have any general questions on the steps that I just put up here? To change from rectangular to polar. All right, so let's try this one. Okay, since we're using the Pythagorean theorem, we're going to end up taking a square root. Anytime you take a square root, it should always be reduced to simplest form. Like if you had square root 9, obviously make that 3. If you had something like the square root of 12, you'd make that like square root 4 times square root 3 or 2 square root 3. Okay, so always reduce square roots as much as you can. All right, so let's convert that to polar. Okay, before I can convert this to polar, what do I need to know about this point? I need to know.
It's in quadrant 1.
Yep, we need to know it's in quadrant 4. You don't have to make an accurate sketch. Just make sure you make a good enough sketch you can figure out it's right, down. Okay, quadrant 4. And Taylor, what's my formula for theta in quadrant 4?
Theta equals inverse tangent phi over x.
Yep. Do we put plus 180?
No.
No, not in quadrant 4, not in quadrant 1 either. All right, so fill that in. Inverse tangent of negative 5 over 3. Okay, whatever angle we get, we'll just round off, round to 2 decimal places. So you get inverse tangent of negative 5 over 3. And if we want to do it in radians, we could. I'm going to do it in degrees. So we get negative 59.04 degrees. Okay, first step. So now we got our angle. And that makes sense because we're in quadrant 4. If you go negative 59 degrees, it's a little bit more than halfway towards the negative part of the y-axis. So that's good. Okay, and last thing we need is our radius. So use your Pythagorean theorem. X squared plus y squared equals r squared. Okay, Josh, what's 3 squared? 9? And Andrew, negative 5 squared.
25.
Add them up. Get 34 equals r squared. So r is the square root of 34. Does that reduce at all? No, 4 doesn't go into 34. 9 doesn't go into it. 16 doesn't go into it. So we can't reduce that. Right, so let's write our final answer. So it's r, comma, theta. And remember, there's 4 different ways you could write this. Once you get one of them, you could figure out, okay, what would the positive version be? Or the negative, or, and so on. So if you get an answer on the test that doesn't match up, try changing it to one of those other 4 ways of writing it. Okay, any questions on that? Okay, I don't want you to think too hard about that problem. 0, 6. Whenever you have a 0 as one of your x or y values, you should be able to do that in your head. We could almost just jump right to the final answer as long as you can visualize where that is. You automatically know the angle. And since you're moving straight in one direction, up, down, left, or right, you already know how far you are from the origin because you didn't move on an angle. You moved up, down, left, or right. So you could just count. Yeah?
It would be 6, 90 degrees.
Yep. So we've gone up 6. Okay, so if I said, how far are you from the origin? Well, you went up 6. You're 6 away from the origin. And you went up. Up is 90. And again, you could write that 3 different ways. Any question on that one? Right. Any other questions in general on what we've done in 9.2 so far? All right, so we looked at the equation of a circle. Okay, it was x squared plus y squared equals r squared. Well, if you wanted to graph that, what letter has to be by itself for the graphing calculator? Yeah?
Theta? No, R. Oh, graph it in the square mode of y.
Y. Yeah, you're going to get y by itself.
Sorry, I was thinking in the polar mode.
So if we get y by itself here, you'd subtract x squared, and then you'd have to take a square root. And remember, when you take a square root, there's a positive and a negative. Okay, so in function mode, this is how I'd have to graph a circle. Let's graph the square root of, and I'm going to let r be 3. Okay, I'll draw a circle with a radius of 3. So it would be the square root of 9 minus x squared. Type that in. Now if I sketch it, that's going to give me what? What do you think? It's not going to give me a full circle. It's only going to give me the top half. Okay, if you want the bottom half, we got to reflect it. Okay, draw that part. Okay, and now we get the bottom half. And again, it doesn't look square because my window is wider than it is tall. And notice it doesn't even connect. It doesn't connect because on the sides of the circle, it's starting to get almost vertical. Calculator has a lot of trouble drawing things that get vertical. But I can make it look more square. So there's a circle radius of 3. And look at everything you had to type in to do that. Now let me show you the same thing in polar. All right, so if you put it in polar, you want a circle with radius 3? 3.
That's what I thought you meant.
That's the whole thing. Okay. We haven't done this yet, but this is what we're going to do tomorrow. It looks more elliptical, but if you actually look at where it's crossing the x and y axis, it's at 3 units on each side. Just hit zoom 5 and it'll make it square. Okay. Lot less work. This is rectangular, polar. Now, what polar is not as useful for is drawing straight lines. Y equals mx plus b, that's the best way to go if you just have to draw straight lines. It's simple, slope, y-intercept, you're good. Polar, it's a little complicated to draw straight lines. But we'll talk about that tomorrow. All right. For the homework, it's on 492. And it's 1 through 16. Okay, 1 through 16.